Okay, so my alternative method involves changing this figure into a trapezium by joining this little line CE right here. And for some like uh, simplicity uh, purposes, I'll just suppose the length of CE to be a variable z. So if we can relate an equation in terms of our area of the trapezium, we can probably express x in terms of a as set in the question or as wanted in the question. So let's see. Here, the area of the trapezium could be expressed as a plus this area of this triangle right here. And then for the right hand side is just the formula for the area of a trapezium. So we have a half times the sum of its parallel lengths, which will be 20, plus, notice that this is 20, this is 20, so we have 40 plus d. And then multiplied by the height, which is just 30. Notice that the area of CDE will be just a half times z times, well, unfortunately, we have to introduce another variable right here. So let's suppose the perpendicular distance from D to CE is y. So this will be just a half times z times y. Now, I'll just fast forward here. A bit of simplification, we get that it will be equal to 15 times z plus 900 minus a half times z times y. Alright, so let's see what we can do here. Well, notice that we have that the triangle CDE is similar to triangle ADG, and I'll leave you guys to check that. So what this tells us is that any corresponding sides of these two triangles, for example, this side and this side, or like this side and this side, for example, must share the same ratio. So we can say that z over 20 is equal to, well, now we ran into the problem because we don't really know the side lengths of AD or DG or CD or DE. However, the thing that comes into my mind is that not only does the corresponding sides share the same ratio, the corresponding altitudes or the corresponding heights of each triangle must share the same ratio as well. So we can have z over 20 is equal to y, which is the height of triangle CDE, over x. Alright, so with this new equation, we can do a lot of things. We can substitute for its values right here. Now, the next thing that I noticed is that x plus y is actually equal to 30 by noticing in this diagram right here. So yet we have another tool for our pretty messy algebraic stuff. Alright, so for the next step, I'm just going to do some quick substitutions and I'm going to speed up the calculation. And that's the end of this calculation. And I've noticed that this method is a bit overkill because it involves some like pretty hard methods like similarities of triangles and like some several substitutions involving those. And in the end, we reach the same result. And I would say that this method is not really worth it for all of this work, and I would prefer the previous method, which ends this video.